Okay, this is Math 2, Unit 12, 12A, Lesson 4, Solving Quadratic Equations Using Square Roots. Going to go over some samples today from the homework, just so we're on the same page and you have an idea of if you're doing it right. I'm not going to do all of them again, but I will run through several of these, and that's the idea. All right, so here we go. The goal here is to essentially solve for x. That's what we're trying to do. And to do that, we're going to be moving things around both sides of the equal sign and then using a square root to eliminate the exponent here. So to do this here, I'm going to first of all add 100 to both sides. A little sample here. Okay, and this gives me 100 equals 4x squared. To get the x by itself, I'll divide both sides by 4. 100 divided by 4 is 25, which now equals an x squared. Now I'm not done yet because, of course, the goal is to get the x by itself to find a solution here. So if I take the square root of both sides, the square root of 25 is going to be plus or minus 5, and that's going to equal x. So x is going to be equal to, for my solution, either a positive 5 or a negative 5. This is not a point, so don't think of it as a point, x, y. This is just saying x is going to equal that or that, and that becomes my solution. And that's the basic process here. We move the whole number over, we divide to get the coefficient away from the variable, we use the square root to find out what's left. It becomes a plus and a minus that value, and that equals x. And we'll use that same pattern throughout the rest of these lessons here. Questions. For number 3. Same idea. This means I'm going to move the 7 over there, so I'm going to add 7 to both sides. So I end up with 5x squared equals 7. I divide both sides by 5, and I'm left with x squared equals 7 over 5. Now I wanted to show this one because it's a little bit weird. When I take the square root of both sides, now I end up with x equals the square root of 7 over 5. I'm not sure if your teachers want you to leave it like that. If I remember from a previous unit, we don't want to leave a radical in the denominator. So if you think about it, this can be written as square root of 7 over square root of 5, or yeah, like this. And so then if I multiply the top and the bottom by the square root of 5, that would make this is like a 1, right? That will make square root of 5 times square root of 5 equal to 5. And on the top, I'm left with square root of 7 times square root of 5, which is square root of 35, is what my x value equals there. I'm not sure if we stop there or not. Again, this would be a plus or minus that. So perhaps you leave it like this. I would ask your teacher to see how does he want you to write that one out. Do you leave it as plus or minus the square root of 7 over 5, or does he want you to get rid of the radical off the denominator and move it up there? Not sure, but I wanted to show that one real quick because it's a little different. You have to be able to play with your radicals again like you did in a previous unit. Let's go back over some basic ones. So here we go. Number 4, same idea. We're going to move the 6 over here. So I end up with 6 equals 11x squared. I'm going to divide both sides by 11. I end up with 6 over 11 equals x squared. And to get rid of the squared, I will take the square root of both sides. So I have the square root of 6 over 11 going to be equal to x. Alright, so like I did before, if I have the square root of 6 over 11 equal to x, or plus and minus square root of 6 over 11 equal to x, what I can do is I multiply the whole thing by square root 11, square root 11, and that will leave me with the square root of 66 over 11, or plus and minus square root of 66 over 11 equal to x. And that's if I kind of factor that out, reduce it out to make it work that way. So that's what I did. I don't know, again, they might want you to leave it this way. Check with your teacher to see. Okay? So some weird ones there. Next one here, we're going to move the 10 over. This is a great question here. I'm going to move the 10 over to there. Minus 10 because of positive 10. And I have x minus 3 squared. The first step here is going to be to take the square root of both sides. So square root of 10 is just simply plus or minus the square root of 10 equals x minus 3. You don't want to forget the 3 here. This is still part of that. All I got rid of was the squared. That stays there. So now I'm going to move this negative 3 over to here by adding 3 to both sides. So this becomes 3 plus or minus the square root of 10 equals x. So my values, if I was to rewrite this for x, could be 3 plus root 10 or 3 minus root 10. Those become the two solutions for x when I work that out. So the key here is that when I have a whole number inside of the parentheses, x minus 3, after I take the radical to remove the exponent, I still have to move that whole number over to the other side. Alright, we'll do another one just like that one. Here we go. Same idea. We have a number inside the parentheses right here. So I'm going to first of all put the 12 over there and make that equal to x plus 1 squared. I'll take the square root of both sides. Now, this is a little different because the square root of 12 is the same as 4 times 3. The square root of 4 is 2, and I'm left with a 3. So that one kind of factors or reduces down to 2 root 3, but again, it's a plus or minus 2 root 3 is equal to, now what do I have left over here? X plus 1. So now I need to subtract 1 from both sides. Now remember how this works. This is a whole number. This is a number attached to a radical. I cannot combine those when I add or subtract. So I end up with negative 1 plus or minus 2 root 3 is equal to x. And that becomes my solution right there. Again, if I write it out as two solutions, I'd have negative 1 plus 2 root 3 and then also negative 1 minus 2 root 3. So a couple different ways that could work there. Alright, let's slide across here to number 11 because there's some more space here. I'm going to move the 4 over there and add 4 to both sides. So x plus 3 squared equals 4. Take the square root of both sides. That eliminates the exponent. So x plus 3 is going to be equal to, now the square root of 4 is 2, but remember it's still plus or minus 2. I don't know which one it is quite yet. Now I can move the 3 over there, so I'll do x equals a minus 3 plus or minus 2. I'm going to put it in the front just so I can work with it a little bit more easily. So negative 3 plus 2 is going to be equal to negative 1. Negative 3 minus 2 is equal to negative 5. So x could equal a negative 1 or a negative 5. So I actually have two possible solutions for that problem. I'll do the same thing with this one. I'll move the 1 over here. So I have x minus 5 squared equals 1. Take the square root of both sides. And the square root of this is still x minus 5, which equals square root of 1 is plus or minus 1. So now I'll add 5 over to here. So x will be equal to 5 plus or minus 1, which means x could equal 5 plus 1, which is 6, or 5 minus 1, which is 4. And those become the two solutions there. Let's look at number 13 real quick. 13. Again, same idea. I'm going to move the 20 over. So instead of a minus 20, I have a positive 20 over here equals 2 times x minus 7 squared. I want to get rid of this 2, so I'm going to divide both sides by 2. So I'm left with 10 equals x minus 7 squared. Now I'll take the radical of both sides. Square root of 10 is just plus or minus square root of 10 equals x minus 7. I want to move this minus 7 over to here. So I end up with 7 plus or minus root 10 equals x. For number 16, again, same idea. I'm going to subtract 20 over there. So I end up with negative 4 times x plus 7 squared equals a negative 20. I'll divide both sides by negative 4. So x plus 7 squared equals positive 5. Not done yet. Take the square root of both sides, and that gives me x plus 7 equals plus or minus root 5. I'm going to move the 7 over, so I end up with x equals negative 7 plus or minus root 5. Again, just not a lot of space here to work this out, so I slid over there. So there you go. Let's look at a couple word problems real quick. Number 19. I don't know what the 6 is there for. It says, a ball is thrown vertically upward with an initial speed of 96 feet per second. Its height after 2 seconds is given by that equation. when does the ball hit the ground? So here's our idea, is we have a graph like this. The ball is tossed up in the air, it does this, and it comes back down. And we want to know, when does it hit the ground? Now the ground point is at 0. So we're finding the solutions for where does it cross the x-axis, where does it equal 0. We know it's going to equal 0 when it starts, and it's going to equal 0 at some point when it finishes. So to solve this, we do the same thing we did before. I'm going to move the negative 144 over to here. So I end up with negative 144 equals negative 16 times t minus 3 squared. I'll divide both sides by negative 16. Negative 144 over negative 16 is going to be equal to a positive 9. So 9 equals t minus 3 squared. I will take the square root of both sides. Square root of 9 is plus or minus 3 equals t minus 3. So now I will move this over here. Looks like this. So plus or minus 3 equals t minus 3. So I'm going to add 3 to both sides. So I end up with 3 plus or minus 3 equals t. So that tells me for my solutions, I can have 3 plus 3, which is 6, or 3 minus 3, which is 0. Now we already knew that, of course, at 0, it's 0. And the question is, when does it fall and hit the ground? Well, after 6 seconds, it's back down here at 0.0. So it's going to hit the ground at 6 seconds. This is when it will hit the ground the second time. Okay? And we'll do the same thing for the other ones as well. So this is the same idea. Again, when it's hit the ground, the arrow goes up and down. When does it hit 0? So I'll let you figure those out as well. But that's a couple practice problems. Hopefully that helps you get going on your homework. Good luck.